Alright guys, today we'll be talking about using the Pythagorean Theorem to solve right triangles, specifically for missing sides. So the Pythagorean Theorem says that in right triangles, so only right triangles, a squared plus b squared equals c squared, where ab are the legs and c is the hypotenuse. Pythagorean triples are numbers that make up a combination that satisfies the equation a squared plus b squared plus c squared. Examples of the Pythagorean triple are 3, 4, and 5, 5, 12, and 13, 8, 15, and 17. There are actually an unlimited amount of Pythagorean triples here because multiples of the Pythagorean triple are themselves triples. So, for example, if 3, 4, and 5 is a Pythagorean triple, if I multiply each of those numbers by 2, I get 6, 8, and 10. And that's also a Pythagorean triple. If I take 5, 12, and 13, and I multiply that by 3, I get 15, 36, and 39. Those are also Pythagorean triples. So the number of triples is endless. We're not really going to worry about that. Just know that Pythagorean triples make it easy when we're using the Pythagorean theorem because it's easy to find those numbers. Just to show you that they are Pythagorean triples, we're going to go ahead and use the Pythagorean theorem. The biggest number is always your c value. So the biggest number here is c, here it's c, here is c. A and b don't really matter. They could be either of the other numbers. So like this could be a and b, this could be b and a. It doesn't matter. But for this one right here, if I use the Pythagorean theorem that says a squared plus b squared equals c squared, 3 squared plus 4 squared has to be 5 squared. So that's 9 plus 16 equals 25. And it does. So those are Pythagorean triples. The question below, it says, do the numbers 20, 48, and 52 form a Pythagorean triple? So we're going to have to check here. Do these numbers work? So my numbers are 20, 48, and 52. Remember, the largest number is always c. So c is 52. The other two numbers, I'm just going to label a and b. Again, they could be flipped. It doesn't matter. As long as c is the biggest number, you're good to go. So my numbers here, I have 20 squared plus 48 squared is 52 squared, because a squared plus b squared equals c squared. Okay, so I just plug stuff in. 20 squared is going to get me 400. 48 squared is going to get me 48 squared is going to get me 2,304. And then 52 squared is going to get me 2,704. So if I add up these numbers, 400 plus 2,304, that's going to be 2,704, which does equal 2,704. So yes, 20, 48, and 52 are a Pythagorean triple. Moving on to some examples with some triangles. It says use the Pythagorean theorem to solve for the missing sides of right triangles. Example 1, I have a right triangle with the sides 6, x, and 10. So c is always supposed to be your largest number. We don't know what x is, so we have to look at the triangle. The triangle is made up of 2 legs and a hypotenuse. I know that this side is the hypotenuse because it's directly across from this little box. So if I look at all of these triangles and I take the little box and draw an arrow straight across to the line, I know that that's going to be the hypotenuse. In example 3, x is the hypotenuse. In example 4, x again is the hypotenuse. It's always the side that's directly across from from the little box, because a little box makes 90 degrees. It's also the longest side that you see. So visibly, 10 is the longer side, but officially, it's also the side across from the little box, so we know it has to be the hypotenuse. So I'm going to label my sides A, B, and C. Again, A and B don't matter as long as C is your longest side. So I'm going to go ahead and use my formula and plug my stuff in. 6 squared plus x squared equals 10 squared. So 36 plus x squared equals 100. If I subtract 36 from both sides, x squared is going to equal 64. Just going to rewrite that up here. If x squared equals 64, I need to get rid of this square. To get rid of a square, I would square root both sides and find that x equals the square root of 64, so x equals 8. If you remember the rule of us taking a square root, we have to take the positive and the negative value. That's still true, but if I said x equals negative 8, this represents a side of a triangle, which is a distance. I can't have negative distance. So in this case, the negatives don't matter. We're just going to keep the positive value. Okay, so x equals 8 is our answer. We're going to do the same thing in example 2. I'm going to erase this to get some space. Example 2 tells us that we have a hypotenuse or a C value of 5 over 7. Our A and B values could be either. I'm just going to say x is A, 4 over 7 is B. Don't be intimidated with the fact that they're fractions. You're just plugging them into a formula. It will be okay, I promise. A squared plus B squared equals C squared. A squared is x. B squared is 4 over 7 squared. And C squared is 5 over 7 squared. So we're squaring the entire fraction. Right now I have x squared plus 4 over 7 squared is going to be 16 over 49. I squared both 4 and 7. 5 over 7 squared is 25 over 49. So what I'm going to do is I'm going to subtract from both sides 16 over 49. These are going to cancel. Because these things have the same denominator, I can just worry about subtracting the top pieces. So x squared is going to equal 25 minus 16 over 49. I'm going to leave the bottom number alone. This is going to leave me with 9 over 49. So if x squared equals 9 over 49, to figure out what x is, I need to take the square root of both the top number and the bottom number of my fraction. So I have x equals, the square root of 9 is 3. The square root of 49 is 7. So x equals 3 over 7. And that's again for example 2. Moving on to example 3. I'm going to go ahead and erase this, get some space. In example 3, I don't have fractions, so that's nice. I know that my hypotenuse is x because it's the longest side. It's across from the little box. So my C value is x. I'm going to say that A is 37.5 and B is 20 just because. Again, I'm always going to use A squared plus B squared equals C squared. I'm going to plug in my numbers, 37.5 squared plus 20 squared equals x squared. So 37.5 squared is going to be 1,406.25. 20 squared is going to be 400. And I'm going to add those together. That's going to equal 1,806.25. And if I take the square root of both sides, I'm going to end up with x equals 42.5. So that's going to be the length of this hypotenuse. Okay, last example, example 4. We have a little rectangle, so that might look intimidating, but it's not that bad. I already said that this is my hypotenuse, so this is my C value. A is going to be 32, B is going to be 40. I know that there's a rectangle and that there's two parts to this, but really, I have everything I need. I have A, B, and C. I really don't need to care that this is here. Okay, to me, it's just this triangle right here. Okay, the rest of it really doesn't matter. I know that A is 32, that B is 40, and that C is x. A squared plus B squared equals C squared. So 32 squared plus 40 squared equals x squared. 32 squared is going to be 1,024. 40 squared is going to be 1,600. And x squared is x squared until we figure that out. If I add 1,600 to 1,024, I'm going to have 2,624 equal to x squared. I'm going to take the square root of both sides to get rid of that exponent. And I have x equals the square root of 2,624. So I'm going to take the square root. And I end up with x equals 51.22. And that is how you use the Pythagorean theorem to find the length of missing sides of right triangles. Remember, if they're not right triangles, you cannot use the Pythagorean theorem.